Hello YouTube world, students, friends, colleagues. Once again, this is your friend Dr. Satish Singhal, PhD, Professor of Computer Science at El Camino College, Torrance, California. Today I'm going to talk about an important topic of C++ data types. A lot of novices are confused with data types, and this PowerPoint is available in my Canvas class. But I thought if I did a video on the PowerPoint, that might clarify a few more things. So let's start. Here's the background on data processing. Computers process data into useful information, and in my course I have discussed in section on IOA technology that input to the computer to get desired output is done in form of data, and data are assigned in C++ data types. Data could be any of the below. You could have numbers that are real numbers or whole numbers. Real numbers can have decimal parts in them, and they could be zero. You could have text that could be single letter or a string of characters. So like SINGLE is a string. But if you take S alone or I alone or left parentheses by itself, that would be a character. Data could also be a state. It could be true or false. Things such as videos, audio tracks, images and colors in them are also reducible to pattern of numbers. Okay. So let's look at some data type from real life data. I'm describing here the data, typical value, and range, and any comment. Person's age on last birthday, typical value could be 17, if somebody is 17-year-old. Range could be 1 to 150, although it's hard for somebody to live 150 years old, but that can happen. And it can only be a whole number because it's age on the last birthday. This is very important to understand. A lot of students don't understand that. Age on the last birthday can only be a whole number. And birthday does not start until you become 1. Grade point average, on the other hand, could have a typical value of 3.5, but its range is 0 to 4.0. Grade point average could be a whole number, but you still have to put 0.0 in there, and it could contain decimal parts like it contains 0.5 here. If I'm only taking middle name initial of someone, like quote, P quote closed, that's a character data type. And their range is uppercase letter A to Z, lowercase a to Z, and they can only be a single character. You could also use like numbers with quotes as character data type, but this is just an example. So we'll discuss like the whole range of them later. In character data type, pair of single quotes are required, but they are not part of the stored value. But if we take someone's first name like John in double quotes, this could contain any number of characters from 1 to some undetermined larger value, and for practical purposes we may fix an upper limit. Okay. Double quotes are not stored in the RAM, and this is Boolean type. If I ask question, I saw a movie Jurassic Park, it'll be true if I saw the movie, false if I did not. That's the data type state that we were talking about. State could be true or false. So these are data from the real life we are looking at. Once we know what kind of data we're going to store, computer will need to know storage space needed. Data is stored in computer in units of bytes. 1 byte is 8 bits, which is 8 set of numbers, which are 8 numbers, where each number can only be either 0 or 1. This is called binary system, and chapter 1 of Singhal book describes binary system in detail. You can read it there. Data width determines size in bytes for any of the data discussed in previous slide. For example, in C++, storage needed to store a person's middle initial would be just 1 byte, 8 bits, pattern of 8, 1 or 0. But large number of bytes may be needed to store a long first name. In general, the whole numbers need lesser storage than the real numbers because real numbers have the dot and there are numbers to the right of the dot. And you may look now, think about it, that the storage space needed for certain data type may be seen as their identity. Okay, you tell computer identify certain variable of certain type and computer will know how much space to store that data is needed. So the storage space needed for data of certain type may be seen as their identity. So how computer programs accept data for processing has an effect whether we need data type or not. First, we are going to talk about interpreted languages. So two types of high-level programming language are interpreted and compiled. So let me just, my explanation here probably won't include that. Chapter 1 of my ebook describes interpreted and compiled languages, but let me just revisit that for a moment. Interpreted language is that you write your program, line 1, line 2, line 3, line 4, and so on. You don't need to compile the whole program first. An interpreter, a software called interpreter, can do the interpretation into the machine language line by line as you run the program. So it'll just execute the first line, second line, third line, and so on. Okay? So it's almost like somebody is reading a Chinese book, and line by line they're telling you meaning of each line in the English. So you can think of that way also, actually. So in interpreted language, program and data input forms a continuum because you're continuing line by line, interpreting line by line. So if data is needed, you can't wait until the end. You need to provide data as soon as it's needed to be provided. So data as needed are fed as program carries out the execution. In such continuous process, computer can determine identity of the data or their storage need in real time when they're fed to the computer. So in a lot of interpreted languages, you don't need actual data type because the operation is continuous. And as you feed the data to the computer, it can determine their identity at that time. So in interpreted languages, computer can allocate necessary space to store and use any data at runtime. Runtime means this is the time when program is running. And computer does not need to know ahead of time whether it's being fed a whole number or real number or someone's name. It can, because we have designed the program such a way that wherever data is needed, it's fed, and the program designed such a way it'll just end up using it right then and there. Okay, so that's the situation in interpreted languages. Let's see compiled languages. Situation is totally different for compiled languages which follow a batch process. So what is the batch process? The compiled program already has a set of instructions in binary code. that code cannot change when program is run. So you're not doing interpretation line by line. Your interpretations, your whole source code has already been translated to a binary code first, and then computer runs that binary code. Thus, computer in execution of compiled languages has to pre-plan the storage needed for data that would be fed to it at runtime. So a certain line number, there is a binary code saying, okay, data name is, let's say, value. Well, it has to know its type in order for computer to create a memory location where it will be used. Since we need to determine as what variable will store which data type, and such finalization is done at compile time, computer need to know identity of those data before the compilation process occurs. Upon compiling, the instructions are compiled into the binary code, and computer just need to know that if I created a variable called value, what type it is, how much storage space it's going to need. Such identity system is called assigning a data type. Now these are deep concepts. I want you to pause the video, or PowerPoint has all this stuff too, and think about it. Okay, think about it, and if you have any question, write them down. So based on these facts, data type is simply a name given to a class of data. Computer relies upon that name to decide the storage space allocated for that class. For example, if computer is told that certain data name is int type, it would immediately know that 4 bytes are needed to store int type. Okay, so that's where data types are created. It creates a class of data which will do certain storage, and it will need certain bytes to store it. That's actually one part of it. There are other things. Okay, so let's talk about what categories are there in C++ data type. There are 3 types of data categories in C++. One is called value type. These are the types or containers that must have some value stored by the user in them before next operation on them can be performed. So basically, they cannot contain garbage. If you don't put anything in them, there will be garbage. And there are cases where you can leave them blank, like single blank character. But otherwise, like for numbers, you're going to need some number. It could be 0, of course, but you're going to need something in there. So they must have a stored value before their use. I call this rule populate before use. You cannot not populate a value type and go ahead and use that. That's bug in the program. So populate before use rule applies to data in this category. Then you have reference types. These store memory or RAM location of program variables or an alias to variable names. These could be references or pointers. We don't discuss pointers too much in this class. CS2 has huge discussion on them. Then you could have structured data type. These types of data are composite of value and reference types bundled into one unit. Structured data type are always user defined, though C++ provides string type that is structured and ready for use. In this discussion from hence on, I'm only going to use value type. And next slide shows the schematic representation of atomic data, structured data, and functions. So this picture is chapter 5. Read chapter 5 of single ebook for detailed explanation of this figure. Atomic data could be just like one of these. I can say this int, double, or character or boolean. But structured data can contain many different types at the same type. A little bit later we'll learn something called struct, and that's where we use it. Struct can also include other struct. Now functions take arguments, and these parentheses means arguments are being passed to the function. Function may not take any argument. They may take a structured data as an argument, or they can take one or more individual atomic types as an argument. So this is the schematic view of atomic data, structured data, and function. Chapter 5 gives more details. Let's talk about value type, because that's the only type we're going to talk from henceforth. So value type could be integral, floating point, boolean, called bool, or enum, enumeration. Integral type could be char, which is a single character in a single quote, pair of single quote, short, int, and long, and we'll discuss them shortly. So integral type has no decimal point and nothing to the right of decimal point. But floating point type always have decimal point, and you will have something to the right of decimal point, could be 0, could be another value. These are called float, double, and long double. Precision of double is twice of the float type, because this is twice the storage space of the float type. Boolean could be only true and false. We'll talk more about that. And enumeration is discussed in chapter 9. I won't talk about that in this video. So integral type can only store whole numbers. Table below gives their C++ names and typical data width or size in bytes. So short is 2 bytes, integer is 4 bytes, long is 4 bytes, char is 1 byte. Char is integral type but only stores single characters. It is integral type because computer stores a number called ASCII code for each alphanumeric keyboard character. And the storage range of each type you can see in single ebook chapter 3. Floating point types, table here shows their size or width. There's a big difference in floating point type. They would have distinctly an integer part to the left of the decimal point and decimal parts to the right of the decimal point. Either both parts, left or right, may be 0. So 0.0 is a floating point type. Storage for some of the floating point type may not be precise, though precision may be improved by using double and long double. This makes some hardcore math. Basically, people have done math only on paper all their life, very upset that computer cannot store certain floating point type accurately. And the reason for that is that decimal type cannot be stored accurately in a binary system. Just some can be, but some cannot be. So don't get upset if you think that computer should be totally precise in storing floating point number. It's not. Based on user preference of displaying data in scientific or business documents and significant figures to be displayed, floating point data types are often subject to display formatting. Display formatting is only done on floating point types. Do not confuse that formatting can be done on integer type. How can you do formatting on number, let's say 101? There's nothing to format. But if you have number 110.15249, then I have to worry about how many decimal points I'm going to show and all those things. You can do a display formatting on floating point numbers, but that does not alter their internal storage. It just puts a formatting mask in front of them. Floating point formatting is discussed in great depth in chapter 4. Okay, so here are the C++ floating point types. You have float, which is 4 bytes. You have double, which is 8 bytes. You have long double, which is also 8 bytes. Their ranges you can see in my chapter 3. I won't talk about that here. You have Boolean type of bool. They have only two possible values, true or false. The magnitude of two values not comparable. You can say which is larger, which is smaller. Although in C++ that's not exactly true. Think of them as two quantum states. Okay? All right. Enumeration is a user-defined type. We will discuss enumeration in chapter 9. Okay, this is very critical. Choosing correct data type for numbers. And that's where a lot of people have problems in the beginning. Everything depends on the experience. More exposure and experience you have, less problems you have. In programming applications, it is critical that appropriate data type are used for numbers that would be used in the program. For example, for data that can only be whole numbers, integral type must be used. Example of data that can only be whole numbers are age on last birthday, we showed example before, number of pennies in a dollar, number of cities in a country, number of students in a class. You cannot have 10.5 students in a class, it's either 10 or 11. For such situations, you should only use integral data type. So when you do your labs, you will be asked to do a IOA document in which you will have to choose data type. Think very carefully. Which data type should be chosen for what number? You can't make these decisions without thinking. That's where thinking becomes very critical. None of above data type can contain decimal parts. Thus only integral type must be chosen for them. In this class CS1, as a practical consideration, we suggest that you always use int for integral type. That's just to avoid hassles. Why integral types as a separate type are needed? That's the question which a lot of novices ask. Though a floating point type can store whole numbers, they do not have some of the special properties that integral types have. For example, integral types are ordinal. Meaning of that is that just by knowing the value of an integral type, one can immediately know its predecessor number and its successor number. For example, if number to be used is 5, one immediately knows that its predecessor number is 4 and its successor number is 6. So ordinals have a fixed ascending and descending order automatically defined for them. Well, this is not the case for floating point numbers. For example, there are thousands of possibilities as to which number is predecessor of 5.5. It could be 5.4, it could be 5.45, it could be 5.455. So floating points are not ordinal. More importantly, arithmetical computation done on expression that only involves integral numbers is much faster than the one involving both integral and floating point or floating point numbers only. So math on integral expression is much faster. And since integrals have no decimal parts, no display formatting is needed for integral numbers. So just remember, when you write your programs, formatting only applies to floating point numbers. While there may be some error in storing floating point numbers in the computer, integral types are storable exactly without any storage error. That's a huge advantage when you want to eliminate errors in computation. Excuse me. String data type. Use of string type requires, at least in older compilers, the use of number includes string. Modern version of Xcode and Visual Studio automatically includes it, but I would still recommend that you include it explicitly just in case your program is being compiled on an older compiler. A string type is structure type and is provided to store text of length 0 to any capacity subject to available RAM. In fact, you can store entire Bible into one string. Zero length text would mean that below declaration is valid, though not useful. I can say string nothing, and then I have double quotes without any space in between. That's a zero length string. Hard-coded value of string type is always enclosed in a pair of double quotes, although double quotes are not stored. And cin operator can be used to input single piece of text. That means no white space. If you have white space, only first part of the text will be inputted. A string type is very versatile, and we'll need a separate presentation to discuss all features of this type. You have to be very careful. The same output could be generated by different data types. Consider these three output statements below in a code fragment. I say cout just integer 9. This is just the line break. That means next output should be on the next line. Then I have cout quote 9 quote. That's a character. Or I have cout double quotes 9 double quotes. Well, if you look at the output, they're all going to look to be the same, 999. Okay. Though all three outputs are same, the data type of 9 quote 9 quote and double quote 9 double quote are completely different. 9 is an integer on which arithmetic can be done. Quote 9 quote is a character on which arithmetic can be done, but results will be useless. And double quote 9 double quote is a string on which doing any arithmetic is a compile error. Many novices find it hard to grasp this fateful and fancy difference between data types, but to be a successful programmer, you should understand that. So pause the video here and view it carefully. Write down any questions you have. Integral types can be signed or unsigned. What does that mean? The range of various integral types are these. Short can store from minus 32,768 to plus 32,767. Int can store from minus 2.14 billion to plus 2.14 billion, and char from minus 128 to 127. Now what if I have distance to some planet, because distance can only be positive, and the value is more than 2.14 billion? Well, C++ in that case allows the range to be made double with a contract that only positive numbers would be stored. When you make a contract with the computer that you are not going to enter negative numbers, and integral data type is used, such data types are called unsigned. So range of unsigned int would be from 0 to 4.29 billion, with the proviso that minus sign will not be appended to the input number. Such numbers are called unsigned because they ignore the sign. Unsigned version that is available only to all integer types is a good mechanism to avoid data overflow when large whole numbers are used. Okay, so what is data overflow? I'll talk about that in a minute. This is very important again. People who come from business division to us, they get shocked by this. Business people, accountants, and many people who use Microsoft Office are in a habit of writing large numbers where commas are used for digit separation. For example, Microsoft Excel will display number which is 10 million, as 10 first comma separator, 3 zeros comma separator, and another 3 zeros. Certainly comma separated numbers are easy to read, but comma as a digit separator is not allowed in C++ programming. In fact, for that matter, it's not allowed in any programming language. Statements such as below, that CO salary, int CO salary is 10 million with comma separator, that's a compile error. Read more details about pitfalls of using comma separator as part of numbers in chapter 3 of single ebook. Danger of data flow overflow. Now I come back to data overflow. When a number smaller than the lowest limit or larger than the largest limit is attempted to be forcefully stored in a variable of certain type, such condition is called data overflow. Data flow overflow can be very dangerous. Example of such loss is below. The lesson of crash of European Space Agency's Ariane 5 rocket, where a piece of software tried to force an 8-byte number into 2-byte data type, and what happened? The rocket crashed. Shows that overflow errors are not trivial and can lead to heavy losses. In case of Ariane 5, the loss amounted to $7 billion and 10 years of preparation. There are some advanced techniques to prevent data overflow, and chapter 3 of single ebook shows them what they are. Okay, that's the end. Thank you very much for watching. Once again, this is your friend, Dr. Satish Singhal, PhD, Professor of Computer Science at El Camino College. Thank you very much.